In this video, we will explain the method of filtration experiments, using examples to illustrate the equipment needed, how the experiment is performed, and what results can be obtained. There are two main methods of filtration. One is called constant flow filtration, which maintains a constant filtration flow rate to the filter. In constant flow filtration, the filter differential pressure increases as clogging progresses. It is possible to check how much liquid can flow before reaching the predetermined differential pressure, and to check the quality change of filtrate in the process of increasing differential pressure. The other is constant pressure filtration, in which the primary pressure, or filter differential pressure, is maintained at a constant level with respect to the filter. In constant pressure filtration, the filtration rate of the filter decreases as clogging progresses. It is possible to check whether a specified volume of liquid can be processed within a specified time, and to check the quality of the filtrate by changing the filtration pressure. These two filtration methods differ in the results obtained and in the equipment required. Selecting the method that best suits the conditions of use anticipated in mass production will enable effective operation of the data obtained. In this part, we will show you how to experiment with constant flow filtration. The experimental method for constant pressure filtration is introduced in a separate video. We will now explain the three steps of constant pressure filtration experiment: planning and preparation, conducting the experiment, and analyzing the results. Step 1. Planning and preparation. The first step is to consider what the purpose of the small volume filtration experiment is and what results you expect to obtain. By conducting the experiment in a well-planned manner, you can obtain a variety of information in a single experiment. When checking the quality of filtrate, it is necessary to determine what means will be used to check the quality of the filter. On the filter's manufacturing side, a particle counter is often used to check the number of particle by particle size. On the user side, it is most effective to analyze the content according to the quality control items of the product. Next, determine the experimental flow rate. If the flow rate for the mass production line is fixed or can be assumed to some extent, it is common to scale down the flow rate according to the scale down ratio of the filter size. Also, by conducting experiments with several flow rates for the same type of filter, it is possible to see the differences in filtration behavior. Filtration methods in constant flow filtration include single pass filtration and circulatory filtration. Single pass filtration is a method in which the filtrate is transferred to a separate tank from the pre-filtrated liquid. Circulation filtration is a method in which the filtrate is returned to the undiluted solution tank to gradually reduce unwanted substances in the undiluted solution tank. The filtration method is selected according to the conditions of use of the filter in mass production and the purpose of the experiment. In this video, we will use single-pass filtration as an example. The next step is to select a test filter. A major advantage of small volume filtration experiments is that many types of filters can be tested with a small amount of liquid. The type of filter to be tested is filtration grade, shape, and size will be determined according to the purpose of the filtration experiment. Suitable filter types vary depending on the composition of various liquids, such as the concentration of insoluble matter present in the liquid to be filtered, particle size distribution, and the amount and size of the material to be removed. Therefore, we recommend that multiple types of filters be compared side by side. Information on filter types and filtration micron ratings can be found on our website. Filter size and shape are selected according to the experimental scale. We have many shapes suitable for small volume experiments, from disc type to capsule type with built-in small cartridges. If you are not sure what kind of filter to try, please feel free to contact us. The final step in the preparation process is to prepare the apparatus needed for the experiment. The apparatus shown in the image is an example of the simplest constant flow filtration experimental line. This type of instrumentation is required to perform filtration experiments. Also, When analyzing filtrate, instruments such as particle counters and particle size analyzers are required according to the content of the analysis. Step 2. Filtration experiment. Before starting the filtration experiment, confirm the flow of the experiment content according to the objectives determined in 1.1 Setting Objectives. In a constant flow filtration experiment, it is necessary to check the differential pressure at each elapsed time from start of the filtration and to collect filtrate. The timing for collecting filtrate can vary from collecting filtrate only at the initial stage of filtration to collecting filtrate at several points during the process of increasing differential pressure and checking the changes, analyzing all of the filtrate collected after filtration is completed, etc. Set the filter according to the purpose of the experiment. In general, the endpoint of filtration is determined by the amount of liquid to be passed through one type of filter or when a predetermined pressure is reached. Assemble the filtration line and prepare the liquid in which the experiment will be conducted. If particles in the liquid tend to precipitate, conduct the experiment while stirring the liquid with a stirrer or mixer to prevent air from entering. Before starting the experiment, adjust the flow rate of the pump. Use a stopwatch and a graduated cylinder to adjust the experimental flow rate. To compare the quality of the liquid before and after filtration, the pump is operated once the line is assembled and a sample of the liquid before filtration is taken. Next, set the test filter. If the filter has an air vent, release it. Depending on the compatibility of the liquid and filter material, the test filter may have difficulty wetting the liquid with a fine filtration precision filter. In some cases, if the filter is not sufficiently wetted, the entire filter media is not used, and the original filter performance cannot be utilized. In this case, we recommend pre-wetting the filter before experimenting. Activate the pump to start pumping liquid. The first step after pumping is to remove air from the filter. Accurate filtration evaluation is not possible when air is trapped in the filter. Therefore, it is important to remove the air immediately after the start of pumping. The air vent is closed when the air has been purged. The stage at which the air venting operation is completed is the starting point of filtration. And at this timing, a stopwatch is used to start measuring time. Depending on the liquid properties and experimental conditions, the liquid level may not come up to the air vent area and air may not be released from the air vent. In this case, close the air vent and turn the outlet side of the filter upward to release the internal air from the filtrate side. Similarly, when using a filter without an air vent, it is effective to turn the outlet side of the filter upward once. From here, we proceed to collect filtrate and recording differential pressure at predetermined timings. After discarding a small amount of the initial filtrate flow for the purpose of flushing the entire line and expelling the solvent inside the filter during pre-wetting, the filtrate is collected. When the endpoint of filtration set before the experiment is reached, the pump is stopped and filtration is terminated. If the filtrate is not collected until the liquid inside the filter has been completely pushed out, the condition of the filtrate will change and the quality of the filtrate will be affected. This will affect the quality of the filtrate. Therefore, it is necessary to stop the pump when the liquid fills the inside of the filter. After the pump is stopped, open the air vent to release the internal pressure, and then remove the filter. If the remaining liquid in the filter is difficult to remove, air pressurization or other means are used to dispose of it as waste liquid. This is the end of the flow rate filtration experiment. If there are multiple test filters, replace the filters and repeat the same procedure. Step 3. Result analysis. Finally, an analysis of the experimental result will be presented with an experimental example. The purpose of the study was to investigate a new filter that can be used for a longer period of time compared to the reference filter that is currently used in mass production. Two types of filters are candidates for small volume filtration experiments. Experiments were conducted by recording the differential pressure at each treatment time and collecting filtrate samples until the differential pressure reached 100 kPa. The particle removal rate was calculated from the result of particle count measurements using a particle counter. Plotting the differential pressure for each treatment time, as recorded in the experiment, we can make this graph. Both of the two newly studied filters showed a slower increase in differential pressure than the reference filter, confirming that they can be used for a longer period of time. The differential pressure trend can also be analyzed by fitting a blockage model to determine how the filter is clogged. The analysis can also be performed by fitting a blockage model to this situation. Please contact us for more detail on the blockage model analysis. In this experiment, filtrate was collected at each timing of differential pressure recording. The unfiltered liquid and the filtrate from each filter were counted for particle count using a particle counter, and the removal efficiency was calculated from the results. Test filter 2, which had the longest life, had a slightly lower removal efficiency from the start of filtration, and the removal efficiency decreased as the throughput increased. On the other hand, test filter 1 maintained the same removal rate as the reference filter, indicating that it is a filter that can be used for a longer period of time while maintaining filtrate quality. Based on the results of these low-volume filtration experiments, moving on to mass-scale testing will lead to more effective and efficient filter selection. We introduced a procedure for small-volume filtration experiments using constant flow filtration. How was it? ROKI Group International designs and sells small volume filtration systems like the one described in this article, and we also offer a service in which you can bring in actual liquids for filtration experiments in collaboration with us. If you are interested in small volume filtration experiments, please contact us. We look forward to hearing from you.